Alright, we're going to talk about the auto keyword. And if you're coming from C, you know that that keyword is pretty much useless. So let's talk about it. Alright, we're back. So in C, the auto keyword was used to let the compiler know you wanted that variable to be basically put on the stack in the function. However, they decided that auto would be by default anyway. So that's why I call it the useless keyword. In C++, you're going to love using auto. One of the most handy tools that you can use it for is to declare variables. When you do not know the type, you could find it would take a lot of work. And you just use the auto keyword and it'll automatically assign it to your variable. So in summary, it really just simplifies your code. And in modern C++, you can use it in combination with templates, iterators. So even with simple types, you can see here, like, you can make X an integer, Y a double, Z char star. The compiler will look at the right-hand side and say, oh, you want this type. So with more complicated types, such as iterators, in this particular example, we have a variable called it. And if you look to the left of that, look how long that type is. You'd have to remember how to type all that out. And even with IntelliSense, it's quite a pain in the ass. However, by using the auto keyword, the compiler looks at the right-hand side and goes, oh, I'll just put it in for you. It's very handy in speeding up your development time. Something that you could never do in C. All right, so let's grab a quick cup of coffee and we'll be right back with some examples. All right, and we're back with some simple examples of how we can use the auto keyword. So what I did is I just did 3 variables. And I'll show you how the compiler will automatically assign a type to each one of these. So if you look here, when I start the debugger, already it knows the types of these variables. That's because it was done by the compiler. This isn't done at runtime. This is done when it's built. Now, as I step through the code, we can see our X, Y, and Z are assigned their appropriate values. Even the string is assigned. And finally, prints out the values. I'm using standard cout only because cout overloads its print functions, so I don't have to worry about formatting codes like I would in printf. So that's as simple as it gets. So I'm gonna go ahead and move on to the next example. Okay, in this next example, I'm gonna show you how the auto keyword really simplifies creating variables or pointers where the name is very long and maybe it's difficult to remember. Now, it may not be so much of an issue with IntelliSense because as you're typing along, you can kind of look it up. But you know, sometimes you have to select from hundreds of different types and you don't know which one it is. So in this example, we start out, we create a container and we initialize it with like 5 integers. Then we assign an iterator to the beginning of the container. If you haven't worked with STL containers before, an iterator is nothing more than a smart pointer. And you can treat it just like a pointer. So if you're coming from C, take the iterator, think of it as a pointer, and you're going to assign it to the beginning of the container or the beginning of the data. In a vector, the data is it's guaranteed to be sequential. It's going to be all together in memory, so you don't have to worry about data is spread in different locations. You treat it just like an array. So here we use the begin method. Now the begin method is part of the vector class, and it just returns a value of that smart pointer at the beginning of the container, and we assign it to it, or short for iterator. Now the type for iterator is this long thing right here, okay? So now you can see why having to remember that every time, let's say if it's out of the boost library, it's going to be even longer than that. You're going to have half a page worth of namespace, and then the type of container, which is right here, and all these scope resolution operators to finally get to your variable name. So then after that, I do a for loop for the iterator not being equal to the end. That just means that's the end, as a pointer to the end of the iterator, printing it out to the console. And as you can see here, I treat it just like a pointer. Right, just like that. So it builds, and there we go. There's our values printed out to the console. So once again, the main benefit of this is to reduce this. So let's say I do auto here, and we build and run again. There it is. Now looking at this, if we look over here, the iterator is already assigned a type for you. This big long thing right here is now taken care of by the auto keyword. All right, that's it for this example. I'm going to move on to my final example. We'll show you how auto will benefit you when dealing with operating system calls. All right, in this next example, we're going to do some operating system calls. And we're just simply going to get the results from a directory, from a listing of a directory. So we're going to start with a path name. I'm going to assign it to a char star. All right, so we're going to use the open directory command, which comes out of the dirent header. All right, so one of the challenges when using operating system calls is a lot of times they have their own unique return values or return types. If you don't know what that is, you have to go look it up and try to find it. In this case, it's dir, capital DIR, and it's a pointer. And you would you would, you know, for just for argument's sake, it would be like this. Okay. Now, if you're in an environment where you don't have IntelliSense, like I said, you have to look it up. An easier way to do it is just to simply use the auto keyword. Now the type is already put in there for you. And as you can see, IntelliSense is breaking it down for you, and boom, you don't have to worry about it. So then we do some checking. We want to see if the directory is actually opened right here. Then we're going to set up some prompts for the output. Next, we want to get the directory entries. That gets returned as a pointer to a structure from the operating system. Readder is what accomplishes this. And rather than having to find that this is how we would instantiate entry, we can just use auto, hovering over it, there it goes. We get the type, which is a pointer to dirent. Sorry, it's a pointer to dirent. And finally, we display the output of every directory entry by creating a while loop. The while loop checks to see if the pointer is valid. We use a cout, accessing the dname attribute, and we output it to the console. And readder is nice in that it bumps the pointer for you, and then when it's done, you get a null, and then it'll exit the while loop. So we run it, and there's the output of our directory, and it works. The takeaway from this example is, and I use this quite extensively in both Linux and in Windows. In particular, Windows has a lot of strange types that have been there since the very beginning. I may not know what the return value is, and I want to avoid a lot of compiler warnings, so I'll just use auto. Now, sometimes I'll even use auto to cheat, and I'll get the value. I'm like, oh, it's that. And then I'll go back in and I'll replace it with that. Another thing that auto is good for is, let's say you're in the Linux domain or Unix domain, you're doing work, and you don't have an IDE like Eclipse where you can use the IntelliSense and see the types as you're debugging it. You're just looking at a raw text editor. You know, you may even be using VI. If you don't know return types, you have to look at the output of the compiler when it throws an error. It may tell you, or it may not. But you can use auto. It's a quick and it's a valid C++ way of getting the return type and get your code done and go on about your day. So that's the final example I have. And with that, I'm going to cue up the exit music.